Welcome to Unit 2, Lesson 4, and today we are going to talk about multiplying and dividing polynomials, which will get us to the remainder and factor theorems, which is fine. It's cool. We're cool. Everybody likes multiplying. Dividing, not so much, but we're going to try to make dividing a little bit easier by kind of multiplying, which in reality, it's really what it is. So let's go ahead and take a look at this right now. So I want to start by introducing the tabular method, which you may have seen before, maybe not. It's kind of like an area model. And this is what I'm going to say to start off. Some of you might see this right here. Yep, my board is off, but we'll work with that. 8 plus x times 8 plus 7. And a lot of you might FOIL this, okay? Firsts, outsides, insides, and last, and combine like terms. That's how I do it when it's 2 by 2. But we can get to situations where I'm not multiplying 2 by 2. I might be multiplying 3 terms by 3 terms, or 4 terms by 3 terms, and it gets kind of a little crazy. And what we have here, this tabular method, is a really, really good organizational way to multiply. So let me just explain it right now. I take, okay, in case you haven't guessed this, I take this, okay, and I multiply it times it. It's like multiplication table, okay? And I guess I should even back up more is I take one of my factors that I'm multiplying and I put it on the top, okay? That's why I have 2 columns, this column and this column. Then I take, all right, my second factor, and I put it on the side here, okay? I guess I could do this. And I make 2 columns because there are 2 terms as well. And then it's like an area model. All I do is I multiply, all right, let's go back to the highlighter, my x times this x, and I get x squared. Then I multiply this 8 times this x, and I get 8x. Then I multiply x times my 7, and I get 7x. Yep, weird. Then I multiply my 8 times my 7, yep, and get 56. Okay, and if you do this right, okay, if you do it right, let me erase all this filth and flarn. If you do it right, something cool happens. Again, I'm going to grab the highlighter. All right. Out of, and I don't like where these arrows are. I personally like to put the arrows out of the corners, okay? So this would come here. This would come down here, okay? This is what I like to do. It's easier. Now, I diagonally add everything together. So I multiplied. These are all products in these inner cells, in these inner boxes. The only thing that's x squared is 1x squared, so that's my answer. But take a look at my x's. I have 8x and 7x. They will diagonally add to 15x. And then last but not least, I have one box with a term that has no x's. And that, my friends, outputs to 56. So we just diagonally add these up, and everything just moves perfectly. Okay, now I do have one note here. It says always start top left. Always start here. Okay, don't start here and always start top left. And there's a reason, not for multiplication, but eventually we're going to go down to division, and it's important to start top left. Okay, so let's actually start to do a couple of these and see how well we can do them. Now, if you want to go ahead and fill out or try exercises 1 and 2, go ahead, pause this video because I'm about to rip them out right now. Let's do this. So, I see that I have 3 terms. Okay, so I'm going to say x squared. I have a positive 3x, and I have a positive 1. So it's going to be 3 terms wide. I'm just going to do this. So there's 1 column for my x squared. 1 column for my 3x. I see that I have, it's close to Christmas, so green and red. three terms here. So I have x squared. I have a minus 5x. The sign is important. When we're multiplying by a negative, it flips the sign. And then a positive 2. So I should have 3 rows across here. Okay? And now, let's fill in these boxes by multiplying. Again, I'm going to start top left. I'm going to fill in this box. I need to multiply x squared times x squared. And I should get x to the 4th. All right? Now I'm just going to go right down this first column. So now I'm going to multiply x squared times negative 5x. That should give me negative 5x cubed. And last but not least, x squared times plus 2. That's going to be a positive 2x squared. All right? That's not horrible. Now, let me try multiplying the column with everything by 3x. So 3x times x squared is 3x cubed. 3x times negative 5x, that's negative 15x squared. And 3x times 2 is a positive 6x. All right. Not too bad, not too bad. Purple this time. Now I'm going to multiply everything times 1, and that's great. 1 times x squared is x squared. 1 times anything is itself. So 1 times negative 5x is negative 5x. 1 times 2 is 2. Now, if we did this right, and it looks like we did this right, everything should line up diagonally. I'm going to put my arrows out of the corner, the bottom left corner of every box. Okay? Now, if I did this right, and it looks like I did, there's only one output here. That's x to the 4th. And if I did this right, let's go to blue next. These two should be x cubes, and they are. What is negative 5x cubes and positive 3x cubes? It's negative 2x cubes. I am just combining, meaning I'm just adding or subtracting. My multiplication is done. When I filled in the boxes on the inside here, those products, those multiplications, done. Now diagonally, I'm just adding everything. Okay? So let's go on to the next one here. Let's pick green. All of these terms should be x squareds, and they are. So if I have 2x squareds minus 15x squareds plus 1x squared, that should give me negative 12x squareds. Okay, and we're just going to continue to do the same thing. Highlighter, highlight. These should just have, oh, that's weird. These should just have x's. There's 6x and minus 5x. I'll rewrite that. So that should give me a positive 1x. And last but not least, this 2, there is nothing to combine with it. It's just a positive 2. This is positive. My x was positive. And my product is wrapped around the outside here. Now, don't leave here. I mean, do the decency of rewriting that out nice like a polynomial. It's x to the 4th, okay, minus 2x cubed minus 12x squared plus x plus 2. This is the product you get when you multiply these two things together. Okay, now if I had to FOIL that, I'd have to FOIL my x squared into this and get 3 terms. I have to FOIL 3x into this and get 3 terms. I have to FOIL 1 into this and get 3 terms. And then it would be, I'd have to combine like terms and everything. This is nice and organized because everything lines up diagonally that you combine. Okay? So let's try the next one. All right? Now I have a little note here. And it says, well, let's read number 2. Use the tabular method to multiply x squared plus 3x plus 1 times x squared minus 2. And then combine like terms. Okay? Because I don't want to just leave like terms floating around in the same expression. I want to combine like terms. But you see these asterisks here. It says must fill in. Are you ready? Missing terms. And I'm going to keep on going with zeros. Okay? I must fill in missing terms with zeros. What does that mean? Let me show you. All right? I am first going to say, all right, okay, well, here we go. We have x squared plus 3x plus 1. So on top, I've got x squared plus 3x plus 1. I know I'm going to have 3 columns because I have 3 terms there. Now, you can look at the next one here and say, oh, I only have 2 terms. No, 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 no. You are missing a term there, okay? I have 1x squared. I have negative 2. How many x's to the power of 1 do I have? I have 0 x's to the 1. So I need to write this as x squared plus 0x minus 2. I need to fill in any missing terms with a 0. If I do not, okay, I'm going to go back to the previous problem. If I did not have this 5x here, okay, these diagonals would not line up perfectly. In order to have those diagonals line up perfectly, you need to fill in any missing terms with a 0. Okay, so I have x squared, 0x, and minus 2. So I have 3 rows. Okay, again, if I did not do that, it would not line up. That does not only count for multiplication, but when we move into division, that is huge as well. Okay, so let's do this quickly. X squared and x squared is x to the 4th, and I'm just going to go right down this column. The beautiful part, 0 times anything is 0. This is going to be 0, 0, and 0. So, yeah, you have to write it, but when it comes to multiplying, easy. And when it comes to adding, I mean, anything added to 0 is itself. So it's really easy. It's just one of those quick steps you should not forget. Otherwise, it can get confusing. Okay? Now, negative 2 times x squared is negative 2x squared. Okay? Now, 3x, I'm going to go down the column, the middle column. 3x times x squared is 3x cubed. That's our 0. And then we got negative 6x. All right? 1 times anything, this last column is itself. So this is going to stay x squared, 0, and negative 2. And of course, we'll do this one in red. My arrows, I like to come out of the bottom left corner. Okay? And I would suggest that's how you do this as well. So I've got x to the 4th. That's the only thing here. I have my x to the cubes line up. So I have 3x cubed and 0. It's a positive 3x cubed. I have all my x squareds lined up. Look how nice that is. Okay. Now, again, if I did not have this middle column or this middle row here, nothing, the exponents would not be lined up that you need to combine. So you have to kind of search for them. I mean, you could do it, but it wouldn't be nice and neat. And again, you're going to need to do it for division. Okay? So, negative 2x squared, positive 1x squared gives me negative 1x squared. All right, now we're back here. Negative 6x and 0 is negative 6x, and this is just a negative 2. So when I rewrite my product right here, that's x to the 4th plus 3x cubed minus x squared minus 6x minus 2. Fantastic! You're getting good at this. You're getting good at this. Apply. Good. Good for you. You're fantastic. You're special. You're good at math. Good. Okay, let's talk division. We are going to perform division. Everybody hates division. We like multiplication. It's the same thing with addition and subtraction. We all love to add. Subtracting, people are like, nah, you know, but we need it. We need it in our lives. We need it. Can't go bye-bye, all right? So, we need to do division, but we're going to do it by multiplication. You like how I raised my voice there at the end? Because the question marks. Multiplication? Yeah, that's right. It's cool. I'm kind of sort of good at that English stuff. Anyways, we're going to multiply these two polynomials right here. Okay? That's how we're going to start the introduction to division, by actually multiplying. All right? So let's take a look at this. Let's multiply these two. All right? I don't see any missing terms, meaning I have an x to the 1st and I have x to the 0. I have x squared, x to the first, x to the 0. Okay, there are no x's. Okay, everything's good. So I am going to say this is 2 terms here, so I'm going to say 2x plus 5. So I know it's 2 wide. Boom. And I know it's 3 tall. So it's a positive x squared, a positive 5x, and a positive 1. So I have my 3 rows, and I have my 2 columns. All right? And I'm going to have arrows out of the bottom left corners, because that's what I do. Now, I'm just going to go ahead and multiply these. This gives me 2x cubed, 10x squared, and 2x. All right? Let me multiply the next one. 5x squared, 25x, and we'll call that 5 times 1, which is 5. And if I write everything out, okay, I add all these up. There's one thing here. It's 2x cubed. Right? I have 2 things here. 10 and 5 is 15x squareds. Right? I have 2 terms right here. That's 27 x's, and I just have my 5. These are all positive. And if I write it out, my product here equals, when I multiply these 2 things together, it equals 2x cubed plus 15x squared plus 27x plus 5. That is the product. All right? So, now that I know this, knowing that result, okay, we want to answer the following questions. Okay? I'm going to try and keep them both on the page. What happens if I divide 2x cubed plus 15x squared plus 27x plus 5 by 2x plus 5? All right, let me explain something to you. I'm going to rewrite this whole multiplication process right on top here. I've got 2x plus 5 times x squared plus 5x plus 1 equals 2x cubed plus 15x squared plus 27x plus 5. Okay, these here are both my factors. Factor times a factor equals a product, right? That's the answer to multiplication. Now, let's go right here. I'm going to make this a simpler concept. Instead of having these factors be these like polynomial expressions in the product, let's just make them numbers like we understand. Let's say 2 times 7 is 14. Okay? I can divide using, if I know my 2 factors. Okay? I can then say, well, 14 divided by 7 is 2. Or I could say 14 divided by 2 is 7. Because if I had to, balance this equation here on the left-hand side, if I divide this by 7, I divide this by 7. 14 divided by 7 is 2, right? I could do that the other way as well. If I divide this side by 2, I have to divide this side by 2. 14 divided by 2 is 7. So if we know any of the 2 factors for the product, I can take my product and divide it by any one of the factors, and it will always equal the other factor. I mean, that's really how you divide. You know the 2 factors, okay? So if I have 24, and I want to divide it by 8, I know that's 3. How come? Because 3 times 8 is 24. All right? We're going to use that same thought process for what I have written up here in blue. All right? So I'm going to erase all this in red. So here we go. Okay, gone. So if I take highlighters, I love you, the product. Isn't this the product here? It certainly is there, poops. And I divide it by one of the factors. The answer should be, well, it should be the other factor there, Sanchez. And it is. Okay? If I take those, it's x squared plus 5x plus 1. All right? And same thing. If I take my product and divide it by one of the factors, the answer should be the other factor, 2x plus 5. Okay? So that's how we're going to do our division, by knowing our multiplication. Now, you might say, Visca, I know 3 times 8 is 24, so that's a lot easier. I'm not going to know that 2x cubed plus 15x squared plus 27x plus 5. If I divide it by 2x plus 5, I'm not going to know this unless I actually have the multiplication done. I don't have that memorized. You're right. And that's a very good question. So how can we divide these polynomials if we don't have the factors to start with? Okay? And it's a little bit something I like to call reverse tabular. Okay? We're going to use the reverse tabular method. What does that mean? We just spent the beginning part of this lesson going over multiplying 2 polynomials using tabs, or the tabular method. Let me go back. Right here. This beautiful hunk of work that some handsome gentleman just did a few minutes ago. This is the tabular method. These are tabs in here, okay? These columns and rows. All right? We're going to take this and we are going to work backward. So now you know why it's important that we fill in our missing zeros, and that we know we multiply the outside numbers together to fill in those inner boxes, and they should all add, okay, as we diagonally output them. So we are going to do the reverse tabular. So here we go. Ready? I know I'm going to divide these two, okay? I'm going to divide these two. And it's important here. I know that this is my product. And this is one of my factors, right? That I'm multiplying. It should equal the other factor. I just don't know what that is yet, okay? But it's so again, if I take 24 and divide it by 8, we know that's 3. Let's even get simpler, okay? Let's take 10 and divide it by 5. We know the answer is 2. I just did division. Okay, but how do I know that works? Because I know the multiplication behind it. Because I know that 2 times 5 is 10. Okay? If this is a factor and this is a factor and I multiply them, I get a product. So let's look at that in terms of our division, shall we? My product is on top. One of my factors is on the bottom, and it should equal my other factor. So here we go, children. Here we go. When I do tabular multiplication, here, let's erase this. It's all nice and clean. When I do tabular multiplication here, what is my product? My product is what's wrapped around the outside. This is my product, okay? This is a factor that I'm multiplying times this other factor, okay? Keep in mind that the outside is your product. So now let's go back to division. When I set this up, the top, the numerator, is my product. Okay, so you want to make a note somewhere here that the numerator is your product. So when I draw a box, I don't know how wide, how tall this thing's going to be, whatever. I know for a fact, all right, that my product is going to wrap around the outside somewhere. All right, my product is going to wrap around the outside. The only thing I know as far as how wide, how many columns, or how tall, how many rows, whatever, I know one of my factors. Am I missing any terms here? I am not. So that denominator, okay, goes on the outside. I know it's x and a plus 3. I always put this here. So if you want to make a note, your denominator goes on the right, and your numerator, which is your product, wraps around the outside. All right? Okay? And nice. And don't forget the numerator, that's the same thing as our product. And our denominator, that's the same thing as one of our factors. Okay? So here we go. Here is the easiest way to figure out how many columns you're going to have. Let's not forget, our answer is another factor. Our second factor, multiplication, is going to be up here. So whatever we can come up with up here is going to be our answer to our division problem. I'm doing a lot of explaining, okay? When we start to do these and start to roll out, it's going to become easier, all right? But I'm doing a lot of explaining. I'm really reaching back here. All right, so here's the best way to determine, in my opinion, how many columns this are. I have 3 terms, x squared, 6x, and 9. That should be my product. The first term comes out of the bottom left. That's going to be my x squared. The next term, 6x, comes out of the bottom left. I have one more term, so I only need one more arrow. My plus 9, I'm going to put it there. Guess what? Wherever this arrow is in the bottom, boom, that's it. That's it. So I'm going to have 2 terms in my quotient for my second factor, all right? Now, here's what we need to do. We're still going to use multiplication. We are always going to start top left. What goes here? The only thing that pops out is x squared, because that's what your answer is. So I need to think in my mind, what do I multiply x by to get x squared? Well, it's x times x. Now that I have that top left header on that column there, what is x times 3? Well, that's 3x. Okay, that's not bad. Now keep in mind, these columns, we're doing everything exactly opposite. These columns, I'll do blue, they should add to 6x. So 3x plus 3x gives me 6x, doesn't it? I mean, it makes sense. So what goes here? What do I multiply by x to get 3x? I multiply a positive 3. Okay? Now look, what's 3 times 3? It's 9. Boom, that's exactly what I have. So what's my answer? What's the one factor I didn't know? X plus 3. The answer is x plus 3. We literally reverse the process. Let me go over this one more time. We know the factor, or excuse me, we know the product here. We know one of the factors. We're trying to get our second factor, okay? So I always start top left because whatever term is out here goes, that's what it came from. I figure out what multiplies, okay? And then I multiply here again, and I add. The only mistake that people make is you got to switch between multiplication and addition. Multiplication and addition. Don't just get stuck on multiplication or addition. Be sure you know what you're doing, which math operation. If you are looking at something like this 3x and this 3x, okay, you should know these two should add to get 6x. Once I have the 3 up here, I know that my 3 and my 3 should multiply to get my 9. Okay, so just know you're always going back and forth between addition and multiplication. That's the one thing that trips kids up. They go fast and they make a mistake. All right, let's try another one. First of all, before you do this, we are missing some terms. But what terms are we missing? All right. I see x cubed. I have 0x squareds. I have 0 x's. Okay, and then I have my x, my term without any x's. So that should be rewritten as x cubed minus 0, or excuse me, plus 0x squareds plus 0 x's minus 27. This is not missing any terms. Okay, what does it equal? Okay, I got to find one of the factors. I have one factor, and I have my product. So I know this is going to be too tall. Remember, that's my right side. X minus 3. It's too tall. My product should wrap around the outside. This should be x cubed. This should be my 0x squareds. Okay, I just did x cubed and x squared. I still have 2 more terms. Okay, so I'm going to say 0 x's. And, ooh, yeah, that should be minus 27. I put 2x. Look at me go. Ha-ha. Minus 27. Minus 27, which means I have 2 arrows here. They need to be in the bottom left-hand corners. Bam, so I just draw some nice. So I'm going to have 3 terms on top. All right? So let's do this. X cubed is what has to output here. So how do I get this product of x cubed? I multiply x times x squared. Now I can multiply x squared times negative 3, get negative 3x squared. These two should add to 0, okay? So a positive 3x squared and negative 3x squared add to 0. This is where the mistakes happen. Now I got to go back to multiplication. X times what is 3x squared? Well, a plus 3x. Now I multiply again for down here. 3x times negative 3 is negative 9x. These two should add to 0. So a plus 9x and a negative 9x give me 0. Now I'm back to multiplication. What do I multiply x by to get 9x? A positive 9. And what is 9 times negative 3? Negative 27. Boom, it works. This is your answer to the division problem. It equals x squared plus 3x plus 9. And I think that's a great place to stop.